All right, we're going to start section 9, or unit 9. This is the very first one. We're doing the grammar of triangles.
Oh my goodness.
I want you to understand that the word grammar in this sense isn't like nouns, pronouns. If I talk about the grammar of, I'm talking about the basics or the terminology.
Use red. The green.
Yes, the green doesn't work well. So it's the when I say the grammar of, that's all the basics of it. When you study English grammar, you're studying the basics of the basis and the terms and everything that go into our language that build it. Okay, so when you're doing English, writing in English, you're not doing grammar anymore. You're using all the rules you already learned. Okay, so the grammar of circles, we're doing the terminology for circles. Okay, there's a whole bunch of them today. You have a note sheet that has something very similar to this on it, and you have this word already on yours, unless the hole went through it and you don't know what it says. But the first word is a circle. What in the world is a circle? I'm going to give you the definition of a circle. Here it is. It's a set of points equidistant from a point called the center. I'm going to let you write that down. I want to make this really clear. You have a circle over here. I'm going to draw it, but you don't have to draw anything on yours. I just drew a circle, okay? And if I put a dot in the center of it, call that the center, that dot is not part of the circle. It is just the point where all of them are equidistant. The red part is the circle itself. So the center is not on the circle at all, and all this white stuff in the center is not the circle either. Only the red part is the circle. The way we name this circle, though, and that's the next little part on your note sheet, we name it with a capital letter of the center. So this particular circle is called circle J, okay? So in that naming part, you want to say something about circle J, and then even when you write it and you write your J, they'll have a little circle in front with a dot in it. So that'll be like circle J.
Couldn't we just put the J in a circle around the J?
That's not how you'll see it in your textbooks, or in your sheets. So you just might want to do it so that you'll be familiar with it. It's named with a capital letter at the center, so you might want to say something about the center being it, and then you can also, in your naming for this particular one, is circle J. Okay. All right. The next term is called a chord.
What?
Chord.
Chord.
This is not little strings that you wear. A chord in...
Where did we just write the circle J?
Just under the word naming.
Oh, okay.
You got it?
All right.
Okay.
Thank you.
A chord is a line segment that links 2 points on a circle. Notice that it's a line segment. I'll let you write that down, and then we'll find one over here on the page here. Okay. So when you finish writing it down, I want you to try to find where you will have a chord on here, okay?
Oh, and it has to be a line segment.
So can it be AC?
No.
Because AC is a line. Which one is a line segment? How about
FJ?
How about JF? Is that a chord?
Yes.
Amy says yes, and Ryan says no. Heidi, you want to break the tie?
No.
You say no.
It's no.
Why?
Because it doesn't... Go ahead.
Well, because it doesn't link both sides.
Yes, it goes through the center, and remember we said that the center is not part of the circle.
Yeah.
So what does go from links the 2 points on the circle?
GD.
GD. So this is what I'm suggesting that you guys do. I'm suggesting you get a marker. I'm suggesting that you highlight or underline the word chord in that color. And then you come over here and you make that be the same color. That is a chord.
Wait, why? What's a segment? Like, does it have to have 3 dots on a segment?
No, it only has 2, and I'm going to draw another chord, by the way.
Segment. Oh, that's a line.
I'm going to draw another chord. I'm going to draw one right here.
Please.
Here is another chord. Okay? You can actually, I'm going to suggest you actually might do that. But, because this one is a special chord, we'll talk about that in a minute, but I'm suggesting you might draw yourself another chord, but you don't have
So
to.
if we already did that...
If you already did, are you making one for yourself? Oh, you can do that one.
Well, if I already did this one, is that okay?
That's okay. It'll be fine. Okay, so this right here that I did in GJD or GD here is a special chord that we will have a definition for in a moment. That's not a problem. It is still a chord. But But if you want a chord that's not a special chord, you just want any chord, we have it this way.
Oh.
And then you can also put your letter in here. We'll call it, I don't know.
That'd be the diameter, wouldn't it?
Yes.
Okay, so I'll underline that.
I'll do P
Diameter, it's a word I know.
and L. I don't know. I'm just making up 2 letters.
Amazing.
PL.
And there's 1, 2, 3, 4. 4 I know.
Wait, what? Ah.
I just named it
Find
PL.
the circle.
So if you on the naming section for your chord, it'll be PL. Okay? We name it with. It's actually a segment.
My bad.
The next one is called a tangent.
Would that be...
We studied sine, cosine, and tangent earlier. And if you remember when we went back to the Latin, tangent meant what? Do you remember the word tangent, what it meant?
Nope.
It meant touch. It means touch.
XM, right?
And so the only one of them that just touches is XM. And let me give you the definition. A tangent is a line in the plane of the circle that intersects the circle in exactly 1 point. XM is the line that is tangent to the circle. Point X, you might want to put this down somewhere in there, is called the point of tangency.
What is? Oh, that?
The point of tangency is the point where the line and the circle touch. So you want to put a little arrow like I did. Yeah, that's good. Like Amy's doing down there. Yep, and right. Good job. Tangency, the point of tangency. Before we can learn about triangles, we need to have the vocabulary together so that when we're talking, we know what we can have conversations with each other.
Or just listen. Oh, that would be
Or or you just listen and you know what I'm talking about. You don't just like shake your head and say, yeah, whatever. Right? All right, circumference. Circumference.
It's the whole circle around.
It's the distance, it's all the way around. It's the distance around the circle.
Yay!
What do we put
That
under the
word.
naming?
And just like you were doing before with that tangent, if you want to do your color and highlight tangent and then draw your tangent on there,
Well, I know what
your circumference is going to be the whole circle itself. It's the distance around. That's why we didn't highlight circle and then do it outside, because circumference and circle could be confusing if we did the both in the same one.
Oh, wait. So, what do we put under the naming thing for tangent?
You can do it like this. XM with an arrow.
Oh.
Okay?
So circle the circle.
I would outline the circle.
what I meant.
Yeah. So like you pick, I don't know, green and underline the green
I can do it.
and then do the circle on top of it. Whatever color, just try to make them coordinate, you know? Circumference. Oh, good question for the naming for circumference. Circumference is going to be the letter C when we have, do you guys remember the formula? Did we do circumference of a circle yet?
Wait. Circumference equals, yeah. I know.
What?
Go ahead. Pi r squared.
No.
No, that's.
It's got a
very
2.
good. Wait.
Got a 2?
2 pi r.
Yes. So for the naming part for circumference, it's going to be C. Okay?
Oh, okay.
And we did those already.
There's
We,
a point C on there.
there's a, no. C for, I'm just going to say C for like the formula.
Oh.
And
So-
circumference, when you're done finding the circumference of the circle or the distance all the way around, you will have a like inches and meters and. All right, we're still going down on your paper, but I had to have more room. The word arc. Arc. Notice that it's not ARK, it's ARC. We're not doing Noah here. We're doing on parts of a circle. An arc is a part of a circle connecting 2 points on the circle. It's part of the circle, as opposed to the chord goes through the circle. This one is going to be on the circle.
AC?
AC is a chord. It should be an arc. That's correct. What else is an arc?
FJ?
FJ is not.
No.
C.
What?
G.
G. GD is not. Notice this is what Amy said a moment ago that I said yes. AC is an arc.
CD. Oh. Or CF.
CF is an arc. That's correct.
Yeah.
GX is an arc.
GX.
Yep. Okay, so you can name one of those. It's a piece. It's just a piece of that circle.
Okay.
It's called an arc. We will be going more into detail about naming them and the different kinds of arcs there are in the next unit a little bit.
How do
So
you
right now,
name
the way you name that, good question, is if I was naming the AC, I'd put an AC and I'd put an arc over the top of it. So if you want to get your colors out, underline the arc there. And since you've already done the circumference, you might have to go underneath it. The diameter is a chord, so it is a chord, but it goes through the center. So it's the longest of the chords you could draw. The chord goes through, it's a chord that goes through the center of the circle. So there's only, oh, that's not true. On this picture, there's only one of those.
Wait.
GD.
GD, that is
Go around
correct.
there.
Remember, a chord goes all the way through the circle. So it's line segment. When you're naming that, you'll do the G and the D, and since it's a segment, you're just going to put a line on it. You guys have already got a color chosen, I'm sure. All right, the next one is radius.
JF.
I heard JF. JF is a radius. The radius is the line segment from the center of the circle to a point on the circumference of a circle.
So if it's from the center of the circle, would we list the center of the circle first?
There isn't a rule about that, okay?
Good.
I want you to note, though, that it's half the diameter. So, Nariah, you did list a radius. There's more than just this for the radius, though.
JD,
Oh, yeah.
Because this is also a radius, and then the backwards this way is also a radius. So there's JD, there's JG, there's JF. I liked the JF because you haven't marked it with the diameter previously.
That's what I was thinking.
So since you're doing the radius, I did mine in particular in yellow, although I did others in yellow, but just to underline it with color so that you have something to visualize it. That would be really good, even for you kinesthetic learners that like to touch things. You doing two different colors here is also going to help you connect that in your brain, okay? We're here to make connections in your brain.
I'm sorry.
Please don't change the slide yet.
Yes, I'm waiting.
Me either.
I heard something about naming it. Since it's in a segment, we're just going to do J. In my particular one, I've got J, JF, and we're just going to put a line above it, okay?
So simple.
But I also need to let you know, actually, on diameter also, there are formulas with diameter and with radius inside. If you have a formula with radius in it, it is going to be a lowercase r. If you have a formula with a diameter in it, it will be a lowercase d. It will not be uppercase. It's actually quite important that you get the right upper and lower cases, because other formulas might have an uppercase r. I'm thinking maybe resistance with electricity, okay? So later in your science life, you want to keep those different. All right. We did all three of those. Arc, diameter, and radius. Here we go. Let's go to the next one. We're going to do secant.
What more?
Secant. Secant, I'm going to just bring it up because this might be brand new for some of you. It's a line that intersects a circle in 2 points. We heard one very similar a little bit ago, like this one.
AC.
AC is a secant.
Is that the one that you were expecting us to highlight for that?
Yes. And but how is this different? How is this different than a chord?
It's a line.
As opposed to a.
Line segment.
That's correct. So AC is a line, and we had a chord as a line. We had a line segment earlier. Okay, so we have secant. I'm going to do purple, and make sure you put arrows at the end if your marker. And it keeps going, yeah. If your marker hides those arrows, put them back on because it's got to be a line, not a line segment. It's got to keep going. And we're just going to name it. We're going to do AC with a line over the top of it, okay? All right, the next one is a sector. I like this one particularly. I think that it even has that in the definition. This definition I'm going to give you is not like the most technical of definitions, but it's going to help you remember it. It's the part of the circle that looks like a piece of pie or a piece of pizza. Okay? And then now the second part here is more technical.
So write the second part?
You can write either one of them. I don't mind. On your homework, that whole thing will be there. A part of a circle that looks like a piece of pie or a pizza. A sector is bounded by 2 radii and an arc of the circle. When we say bounded by, that means that's the edges of it. It's bounded by 2 radii and an arc. That's the pieces, the sides of it. Oh no, I should have checked that out. FJ, I think we do have to name it in that direction. I think we have to start with the radius in the center.
Huh? So JFD?
So I think we need to do FJD, and then we have a sector. I think it's going to be in front. You're going to have like a piece of, I think it's going to look something like a little piece of pizza. Yeah, we'll put some olives on it. So we concluded that the sector is this whole region in here. The whole region in here. It's the region bounded by, okay, the radii and the arc. All right, now we have a segment. This is a different kind of segment than a line segment. This is a segment of a circle. The segment of a circle is the part of the circle bounded by an arc and a chord. This is another little shading thing. Can you find a segment up there?
What's a chord again? AC?
AC is where it is. And so it's going to be this portion in here.
Oh.
I can write.
Doing this in a little bit, in several, I don't know if you call it several days, but in several class periods from now, we will be doing something with this. You will have this sector right here. And then we'll have this segment that you have here in purple that we just did here also. And I think that looks a whole lot like a pizza with the crust. And then that segment is the crust of the pizza.
Yeah.
Okay? So this is like all of the toppings, and then and the sector is the whole piece of pizza, and the segment is the crust.
Pie.
Or the crust on the pie. That's correct. Blueberry pie is the one I have there. Okay.
I got like a raspberry pizza pie thing going on here.
Okay, we just did segment, sector, and segment. Now we're gonna this next part you're just gonna watch. Are you ready? We're gonna talk about circles that are tangent to each other. Remember we said the tangent meant what?
Something. It only touches on
Touch.
one point.
That's right. So if there are 2 ways that tangents can be. Circles can be tangent. They can be tangent internally and externally. Let's look at that. These, what do you think? Are these tangent internally or externally? Internally. They're only touching in one spot, but they're on the inside. One's on the inside of the other. This one is externally, okay?
It's like a bubble.
It does. Or a sideways snowman, okay? All right. Now, but if circles are not tangent,
then you put NT.
then
Not
this is not tangent. That's not tangent. Why is the second one's not tangent?
because it's like half on the inside, half on the outside.
Because they touch 2 times. All right. And you only can touch once for tangent. That one's not tangent. That last one, these last ones are called concentric circles because they share the same center. Okay. They're called concentric. Notice the word kind of center.
Are concentric circles.
These 2 ones, yeah, that's like a bullseye.
Eyes are concentric circles.
Yes, inside. Yes, inside. Not the, yes, but our eyeballs. Yes, have concentric circles. All right, now I can draw some tangent lines though. If I wanted to draw a tangent to the big circle and the small circle, how could I do it?
You could like. Well,
I want a one line that's tangent to both.
Well,
A line or
A line,
Oh,
line
you
segment or a
like-
line.
well, you would
a
put like a dot.
diagonal line?
Oh, I can do a diagonal.
Yeah.
Okay,
Like
I
this.
could do a diagonal. I'm gonna try. If I go like this
That
and I come,
touches in one place.
touches both of them in one spot. There we go.
Could Does it matter if it's inside the circle?
Let's try. So if you wanted me to go like that, would that have been a tangent?
No, like from center to center.
Oh, like from here to here? Oh.
Yeah.
Like a bite.
Yeah, like a bite.
Except
or a
Not
train.
a bite.
Tangent.
Looks more like a
But
What-
unless it's
Green
if
machine.
it's
It has
a
to-
segment, but if it's a line.
Yeah. Tangents have to be not go through it. It
Okay,
has to
well-
just touch it.
What about like without it, like doing the same thing just without going on the inside, like from the point to the point?
Like
Does that make
edge
sense?
to edge.
Like yeah.
Like-
Or would that? No.
See, I did this one, didn't I? A minute ago? Wait. I did that one, right? Kinda. I'm gonna kind of pretend. All right. What else did you want, Amy? What's the other
Is
one?
it possible to go like a straight line
Yeah.
and just yeah?
Well, because that's a straight line right there. So I don't understand what you meant by
Wait.
straight. Flat?
Like from here to here.
Oh, from there to there. I think we're talking about common tangent. I think we're gonna stick with lines, not segments.
Okay.
Okay.
Oh, so it's got to be something that like keeps going.
Yes.
Okay.
Yes. So that one wouldn't work. What's another one? And I should put little arrows on the
Well, you
ends.
could do it like the opposite way.
Yeah.
Okay, I could go up instead of right. I can go up, right? So I can do like that, right? Oh nope.
You can put
How else?
them both on top.
Oh, both on top. So I can go like this, like that.
You could do it both on bottom. So.
If I can get it. Yeah, that's gonna be really hard. There we go. Almost. Oh, I can't pick it up once I draw it. That's the
and
bad.
that was really close. That was close enough.
So that one, oh, after I deleted it, I can't. There we go. Close enough. Okay, so then I can also do it down here, right?
Mm-hmm.
Ooh, that one was pretty decent. Okay, now, the first two that I drew, these ones, are common on the inside. That's a common internal tangent because it's between the two. These ones are called common, what do you think?
Outward.
External tangents. All right. So I have. We can have a common internal tangent and a common external tangent. Here are the internals, and here are the externals. Okay, you guys led me there. All right, good job. You didn't have to write that down. All right, here's some new theorems. I'm going to give you your formula madness, so make sure you get that out. All right. Some new theorems. This is first of all, we're gonna look at the first three, and the bottom one is one of your formula madness ones. So you'll need your term sheet and your formula madness out right now. All right, the first one at the very top, number one, is a tangent to a circle theorem.
What?
A line drawn tangent to a circle is always perpendicular to a radius of the circle drawn to the point of tangency. So if, right up here, I have this line, at that point of tangency, I can draw a perpendicular from the radius. The converse is also true. This is one of the only converses I provided for you, although there are multiple places that converses are true. This is the only one that I provided for you. The converse of a tangent theorem, it says if a line is perpendicular to a radius of the circle at its endpoint on the circle, then the line is tangent to the circle. So this is the backwards. If I have a line that's perpendicular and touches the circle, then it's a tangent. It's perpendicular to the radius. This is a formula madness here. Two tangents to a circle theorem.
Why is my eye twitching?
All right. If you have two tangents, they meet at a common endpoint outside the circle. So let's read it. It says, if two segments that from the same exterior point are tangent to the circle, then they are congruent. So that, for your particular ones, let me see which one you have. Yours is down here at the bottom. It says, what is congruent? That's where you're going to write this. So in yours, you have the letters C and A and B,
Oh,
correct?
we can't just mark them congruent. We have to write like AC is congruent to AB.
Oh, so you don't want to have to write AC congruent to CB. You just want to go like that?
Yeah. I don't care.
Can we?
All right, I'll let you just mark them. You can just mark them.
Cool.
Cool.
That's fast.
Yes. All right, mark them.
I
The
don't know
only
what
trouble
that
is I'm afraid that eventually The reason I have you do the formula madness is so that when you see it enough times, when you see it on your homework or in the real world, you go, oh, they're congruent. So you marking them congruent, you're going to be able to know that? Okay. So they're congruent.
Does it matter what order the
letter.
and then you do actually write the letter?
Good question. It does not. So like triangles, they were in a certain order, but this is not.
Yeah,
I could have said CB. I mean CA and BC. Here's something interesting. This is an example you don't have to do anything with. Just watch. Okay. So I have a circle. Okay, and I have a radius. And I tell you in this purple instructions over there that BC is tangent to the circle. They want you to find this radius. What do you know about the length of AC and CB? What's the relationship between those two segments?
I don't know, but we can use
But they're perpendicular. That is correct.
So that's a right triangle.
So that's a right triangle. So what can we use for being
A squared
plus it is tangent, that's right, but we can't we can't use tangent because we don't know these angles, Heidi, so you're right. But we could have maybe used some tangent, sine, cosine type, but we can't. We have to use Pythagorean theorem. So if I did that, this would be r squared plus 16 squared equals how much?
8 squared? No, yes.
It would be the 8 plus the r.
How long is this whole thing?
It would be 8 plus r.
8 plus
plus
r
r, no
squared.
wonder.
Okay, I'm gonna write that down for you. I have 8 plus r squared equals r squared plus 16 squared.
Yeah.
Your homework right now will not have this kind of thing this time.
Yay.
But I'm showing you this because eventually it will. And you will need to have a reminder on how to write this r plus 8 squared. R plus 8 squared is up here at the r plus 8 times r plus 8. This is something from algebra we haven't seen in geometry yet, okay? So we'll have r times r equals how much?
R squared.
R squared. Then we have to take that one again and come over here.
Can't we just square everything?
8R. 64?
What?
Oh, we'll get 61 in it, yes, because I just did this one. I just did this.
Yeah.
Then we have another
I just
8
distributed
plus
the
r.
squared.
Yeah, you can't. That's the one part you can't do. And then we'll have, oh, I should have done that under
64. R squared plus
this.
8R plus
Plus another 8.
Wait.
R plus 64.
Amy, ask me some questions because I need you to know.
Well, I got it.
You got it now?
Yeah.
What we did is we did the distributive property 2 times. This is something from algebra. You can't just take this squared and give it to both of them and be done. And Amy asked a good question. Why can't we just square root both sides? Amy, if we square rooted this section over here, yes. But square rooting this when it's not, with that plus inside, it doesn't just make r plus 4. Because there's a plus in there.
What I was saying is what I realized what we did afterwards, but I was like, I didn't see the 2 was on the outside, and I was like, why can't we just do the square first? Like, take the 2 and square the 8.
Oh, right,
Yeah.
right. We have to, this
It'd be
squared
2R
thing means,
and then
yes, exactly.
square
This
it.
squared thing right here means this up there. So we have to do the distributive property.
I just didn't see that the 2 was on the outside. of the
Right.
parentheses.
Those 8r and 8r becomes what?
16R?
Yes, 16r. Here we go. So this is how it comes here. So we have this. That's what we did. What's going to cancel out?
R squared.
The r squareds are going to cancel out because we're going to subtract them out on both sides, right? Like I said, you will not have one of these kind on your homework this time, but it's like a little advertisement to get your brain ready
not that great
for
an
something
advertisement, so
that you are going to see in the future. Your r squareds cancel. We now are going to move that 64 over by subtracting.
192.
I heard 192. We're going to divide by the 16. 12, I heard. 12.
Oh my god.
12 is our radius. We will see something similar to this, but we won't have this little squared thing
That's
just
nice.
yet, okay?
That's nice.
There will be some in the future, but not. So I needed to give you that little advertisement. Here's another interesting. This time we're going to have segments. You don't have to write this down if you don't want to. The segments of 2 intersecting tangents have the same length. We just did that one already. So if I gave you this, and I told you that you have these equations, how can I set that up?
So 7x minus 3 equals 11.
7x minus 3 equals 11. I totally agree with you. Don't
I
have to write this
zero.
down. What am I going to do to solve this?
Plus the 3
Add the 3 to the other side. It's going to be 14, right? The divide by 2 and you'll to 7 and you'll get 2, okay? All right, nothing you had to write down, just to watch. Sometimes it's nice to just get to watch. Here is where you can start writing down. We're going to do this together for homework. This is part of your homework, okay? Number 12. We skipped a whole bunch. We skipped the first 11, which is a matching, to all those vocabulary words, just to get them in your brain another time. Number 12, it's telling you in the instructions to determine if it is tangent. How are we going to what's the relationship between a tangent and a radius?
Wait.
They're perpendicular.
They're perpendicular. So we're going to try to decide if this is a right angle right there. In other words, we're asking, is this a right triangle? How do we decide if triangles are right?
Go ahead.
Yeah.
Go ahead. Okay, so c squared and then leave a space and then do a squared plus b squared.
That's to determine if it's obtuse or acute.
Oh.
We want
a
it to be
squared
right.
plus b squared equals with a question mark over top.
Yes, equals with a question mark over the top of it. And so
Oh,
the
totally.
trouble is we have a whole diameter here. We have a whole diameter. We only know this portion's 8. How do we know what this portion is?
4.
I heard 4. Is that true?
Oh, wait. No. Wait.
Okay, what did you say?
We have a whole diameter right here, and we know that portion's 8. How do we know how much that one is?
It's 8 also.
I heard it's 8
The
also.
whole thing's...
I heard she said it was 4.
Oh, I thought you were meaning the
She
whole
said
thing
it
was
was-
8. I thought, yeah. It's gonna
If
be
one side is 8, the other side
This is 8. So how big is this whole thing?
16.
All right. So then when we're doing our Pythagorean theorem, we have, is this a 3, 4, 5, by the way?
12.
Yeah.
12, 16, 20. Is this a 3,
Yes.
4, 5 multiplied by
By 4.
Where's my sticky note?
Well, 12 would be
Times
3,
4.
4, then 20 would be 5.
16, 12. Yeah,
Yes, it is. So then we don't have to use the Pythagorean theorem because you know your Pythagorean triples. We can just say yes. All right?
Yes.
Wait.
Nice.
Why are we saying yes?
Because it's a 3, 4, 5. 3, 4, 5 is a Pythagorean triple. It makes a Pythagorean. So that's
Why
why
do we have to prove something?
that's why you memorize 3, 4, 5 is because you know it works with the Pythagorean theorem. And if we multiply any Pythagorean triple by a number,
Oh,
And get
wait,
it.
we're determining if the line AB is same to the circle. So we're saying yes, it is, or no, it's not.
yes, it is
Okay.
because
If you want to write yes tangent to help keep it
Well, I
straight.
thought we had
Yes.
to like find some weird number thing to come up with an answer to something.
no, we're saying that it is
Those
tangent.
decimals.
Okay?
Say what?
Yes, it's tangent.
Oh, God.
Are we doing another one of the same problem?
Please?
Yes, number 13.
Oh,
Let's do
yeah.
number 13.
So,
I need to go to the
Question. All right. So we're trying to prove that this is a right triangle because we're trying to also prove that it's tangent. So what squared plus what squared will have to equal what squared?
A plus. Oh, sorry.
And what's A, B, and C?
And there needs to be a question mark above that.
Yes.
A and B are interchangeable.
Okay. So which ones are A and B then?
A can be like 5.4 plus 5.4.
no, it would be the 8.1.
8.1. This is the A.
But look, there's only we only have 5.
Oh, you're right. For the same
Oh.
reason, we have 5.4. So that's going to be 10.8.
Yes.
Yeah, okay.
Ah, thank you very much for observing that. We were
So
talking
then
about
they
that
could
today, that
be-
math is not just math. It's also teaching you about details. You got to remember
Still
them.
math.
It is still math.
Details in math.
Yes.
But
But
still-
it's one of those realms that does teach you about details. Okay, so C squared is going to be 13.8. 116.64?
Yes, ma'am.
116.
8.1 squared?
65.61.
Ah!
Sorry, I won't go so fast.
Isn't that the problem?
Wow, that's a big number. Did I do that right?
And then 13 squared is going to be somewhere in the almost 170, I think.
Oh. 190.44.
Yeah.
13 squared is 190?
190.4.
13 squared is 169.
Uh-huh.
Well, it's
13.8.
13.8.
I know. Okay, 190, what again?
190.44. Did you get that
Right.
right as well?
Boy, but technically there's no. So you can just like add on.
So when we add these two together, do we get 190.44?
Oh, that's what we're doing. Never mind.
No.
64?
What do we get once?
182.25.
That's what I got.
What?
25.
Yes.
So is this a tangent? Is AB a
No.
tangent? No, not tangent.
Oh, so this is one of those things where it's kind of like they have to be equal, and if they're not equal, then it's sort of like it's
That's
not
exactly
a right,
right.
angle, or it's not in this case.
Yeah.
That's
tangent.
right.
Got
That's
it.
right. Got
I'm
it.
catching up here.
Good. Glad you did. Number 16 and 17 is find the segment length indicated. Assume that lines which appear to be tangent are tangent. All right, so if the line with the 12 here appears to be tangent, so it is tangent, where's the right angle?
What? Wait, it's
Right here?
wait. Okay.
Right in between
Oh,
12
yes,
and
right there.
questions.
This is the right angle.
Question is what?
We're looking for the question mark. I'm going to call it R. Can I call it R?
So wouldn't that one side be 2R?
Yes. This side would be 2R.
Brilliant.
Brilliant. All right, so how are we going to do this?
The same way.
Mm-hmm.
but-
I want to caution you, do your 2R, put a parenthesis around it. Plus what squared?
Well,
Yeah.
Equals,
you gotta square this stuff.
yes.
You gotta help. Is there like a
So,
thingy that tells me to do?
So 2R squared becomes what?
4R squared?
4R
Yeah,
R
4R.
squared. Mm-hmm.
Wait, R squared? Yeah.
Why would it still be? Oh, never mind, because you don't have an actual number thing to.
I don't know what 17.4 squared is.
302.76 is what I got.
17.4.
verified.
Good job. I'm going to subtract.
302.76.
Yes. I'm going to subtract that 144 to the other side. Tell me what that is, if someone can.
158.76?
Here.
Whoa, wait.
Subtracted 144 to the other side.
Okay.
Okay.
Square root of that, aren't I?
Not yet. Don't take the square root yet. Divide by 4 first.
Oh.
158.76. Is that what that is?
Yes. Divide by 4.
39.69.
Verified.
Why does it have to get more complicated as I get older?
Just how it works. Because
Everything
God knows you can handle it. Because God knows you can handle it. That's we were talking about that before.
About this.
What's 158.76 divided by 4? Someone help me.
I didn't even do that.
39.69.
89.6. 39.
Say it again so I don't have to.
39.69.
Now, how are we going to get R by itself?
Take the square root.
Take the square root. Now, when we take the square root, we have to have 2 answers.
Yeah.
We
Wait,
do?
what?
Yes. What happens when you take the square root on an equation? You have 2 answers. A positive and a
And then
negative. But the R that we have, our R, that's not like a seal, R. Anyway, so we got the R that we have right now cannot be negative. Why?
Because you can't have a negative segment or line or.
That's correct. The length of anything in this physical scenario cannot be negative. It is not a scalar. It is a scalar and not a vector
Stop.
that we did in science. So we don't need to write the negative in this case, but realize that in algebra you have a plus and a minus. But in this geometry particular problem, we can have a negative R.
So we don't. So we just say R.
R equals.
Square root 39.
No, what is 39.6?
6.3.
6 point.
What?
Is that what you got?
Well, I put the thing in my calculator and did square root of 39.69.
Yeah, that's what I got.
6.3.
Okay.
Yeah, I had something else in front of it.
Okay. I am going to skip 17 for a moment because we are
No.
running out of.
Yeah.
All right, here we go.
Wait, we still have like another whole lesson, don't we?
Two more tests. All right, here we go. This one, be really careful here. It says find the segment length indicated. Assume that lines which appear to be tangent are tangent. Now, we are only finding this little teeny purple piece down here. But how much is this yellow piece right there?
We can't.
How
There's
much is
not enough
the
information.
how much is the yellow piece right there? We can.
Oh.
Question mark.
2 times as much as instead of
No.
Something minus x. If the question marks
No.
it.
What
It
is
would be
that yellow
plus.
piece?
It would be-
What of all those vocabulary words that you were doing?
It's a radius.
What?
It
It's a
looks
radius.
like
The yellow is a radius. Do we?
half of the-
do we-
It's 6.5.
It's the same as this radius right here. It
I
is
just said
6.5.
Oh, I mean, it looks about the same size as
That's
that.
an R.
Hard.
I know, me too.
That's an R. Oh, I might have been wrong about that little thing that I told you a minute ago.
What thing?
How much is that then?
Oh, 6.5 plus X.
R.
Or R. In
Oh.
this case.
We're looking for R, so I think I was wrong about you don't have to do it. That was just an advertisement. This was not an advert. This you have to do this. All right. So what squared plus what squared equals what squared? Uh-huh. Oh, that was supposed to be a 6.5, not a 6.4 right
Wait,
there.
6.5 plus R.
Squared.
Yeah.
Okay, 6.5
plus-
squared plus 6.5 plus R
No,
squared.
6.5 plus r squared is the c squared.
What?
You're right. Equals plus 7.2 squared equals 6.5 plus R.
Oh.
Amy, ask me some questions.
Wait, so the big fat thing in parentheses equals
the hypotenuse.
other two things.
Yes, because it's the hypotenuse. Well, you guys already told me that this over here became 90 what point what?
94.09.
Well, I subtract I did all that and I have 3R plus R2 equals 51.84. That was like my last step thing that I did.
Wait, was it 0904?
94.
That you have to use what's something called the quadratic formula, and
And you
it's
don't wanna
complicated.
do
You don't
that.
want to do that. This is so much better. All right, we're gonna do the Amy way a minute a little ago. She said, why can't we square root both sides? Well, that's exactly what we're gonna do. We're gonna square root both sides. What is the square root of 94.09?
9.7?
That's what I got.
How much?
So
9.7.
6.5 plus R. Wait, so are we literally just writing that like
You're
right
just gonna
next
bring
to
this
it?
right down here.
Okay.
No, do that part.
Oh, this is
Right there.
easier.
Mm-hmm.
Okay, yeah.
I'm moving it up because I didn't have room to write. So, and then
Was it exactly 9.7?
Yes, ma'am.
Fantastic.
So when do we know when to square root and when not to square root?
When you if you have an R, and so you're going to have an R squared on both sides, they'll cancel. Then you could have done that. But if there isn't something on both sides, try your best to square root if you can. Okay.
Okay.
All
What
right.
do we do if both don't work out? Or will one?
Well, I will be giving you I will review what you did in algebra with what's called the quadratic formula.
okay,
to
where
be
do
able
I
to
go
do
from
that.
where
Okay.
to go?
Sorry. Square root both sides.
Okay.
The square root and the square undo each other, and you're going to have 6.5 R on that side.
9.7.
9.7. Now we're going to move that 6.5 to their side.
Oh, so much prettier.
Uh-huh.
Just listen to me. I have no clue what I'm talking about, but a lot of what I say makes sense to other people. No, it doesn't. Never.
We're going to subtract the 6.5 to the other side,
Oh!
and
pretty
we'll get
number.
R equals what, Amy?
3.2.
Uh-huh.
Pretty number.
All right. All right, we did number 20. All right, this one is going to be better, I think. Solve for x. You have two tangents. Assume that lines that appear tangent are. We have two tangents, and they meet out here.
They're equal.
They're equal. We're on your formula madness. You're going to go deek deek to be done, right?
Wait, yeah.
So we're going to go 8x equals 9x minus 2, correct?
That's easy.
That's nice and beautiful. We're going to subtract the 9x to the other side and have
Or
negative x.
Add the 8x and add the 2.
You could do it that way too. You could move the
What?
8x over there and the 2 over there. So you'll have x equals what?
2.
Negative 1x plus.
But it won't be
2.
just x equals 2.
Say plus.
What do you mean?
Solve for x?
Oh, wait, yes, it will be.
Yes.
I'm sorry.
Solve for x. We don't have to plug it back in. All right.
Wait.
All right, this is what we learned in this section, okay? You learned a ton of vocabulary. You learned that circles can be internally and externally tangent to each other. You learned some common internal tangents of the different lines that are tangent to circles, and you also learned two interesting concepts, and they're not just interesting, they're actually your some of your theorems, the first 3 of them. The tangents are perpendicular to the radius. You also learned that segments of 2 intersecting tangents have the same length, as long as they you have to intersect outside. All right. Goodbye.